Ladies and gentlemen, thank you for joining us today and welcome to our session, Can Women Farmers Outperform Male Farmers? Exploring Disabling and Enabling Factors in Africa and Asia. Without any further ado, please welcome our chair, Mrs. Bina Agarwal, to open the session. Mrs. Bina, the screen is yours.
Thank you. Thank you very much. Welcome everybody. And there was a technical glitch. That's why there was a delay. But I'm Bina Agarwal, Professor of Development Economics and Environment at the University of Manchester in the UK. And welcome to our panel, Can Women Farmers Outperform Male Farmers? Now, let me say a few words to set the context. As agriculture gets feminized globally, the income and food security of rural households, as well as a country's agricultural growth, will depend increasingly on the productivity of women farmers. But their ability to deliver can be seriously undermined by large gender gaps in access to land, inputs, extension information, and so on. Now, FAO's 2011 assessment based on then existing studies was that if women farmers had the same access to inputs as male farmers, their yields could be raised by 20 to 30%. But studies on the gender gap in farm productivity are relatively few. Those for Asia, you have mostly for Africa, and for Asia, they're even fewer. Now, this panel fills a gap. It brings together 4 recent papers from Africa and Asia, which compare the economic performance of female and male farmers and the factors underlying any differences, such as soil quality, crop choice, managerial experience, and so on. And the panel also examines ways of overcoming gender constraints, including intensive agricultural training, and for the first time, the effect of women farming in groups rather than individually or in family farms. So our speakers will be Talib Kilik, Senior Economist in the World Bank's Data Development Group, Washington, D.C., Kanika Mahajan, Assistant Professor at Ashoka University in India, myself, and Chris Udre, Professor of Economics at the Northwestern University in USA. And we will be speaking in that order. So we will each speak for about 10 minutes and then move to Q&A. Please write your questions in the chat. So thank you. And with those words, let me pass the baton to Talib. Please mute your microphones.
Hi, Bina. Thank you so much for the kind introduction, and thanks everyone for joining us. My name is Talib Kilik. I'm a senior economist at the World Bank. Today, I want to share with you the preliminary findings from ongoing research on gender gap in agriculture productivity, the role of soil quality in Malawi. Agriculture is key to rural livelihoods in Africa, and improving agricultural productivity has been a long-standing goal of African governments. Closing the gender gap in agricultural productivity is one way to increase aggregate productivity. However, the evidence from several African countries indicate that female managed plots could be up to 66% less productive than their male managed counterparts. And at least across 3 of these African countries, it's been estimated that closing the gap can bring nearly 500,000 out of poverty. Recent research has relied on decomposition methods to identify the contributions of gender differences in levels of factors of production versus return to these factors. And despite this surge in the research, we've seen that there are some gaps, which I'm going to get into. But in general, we've seen that endowment effect explains majority of the productivity gap, driven by mostly higher levels of fertilizer use and male labor inputs on male managed plots, as well as greater incidence of cash crop cultivation. And the remaining structural effect is driven mostly by higher returns to the same factors on male managed plots. So despite the surge in research, the role of soil quality in gender gap in agricultural productivity is yet to be explored, but we know that soil is a key input into agricultural production, and unobserved plot level heterogeneity, including soil quality, has been shown to be key to explaining agricultural productivity outcomes. And accounting for soil quality can alter conclusions regarding the relative contributions of other factors towards the gender gap and potentially resulting in different policy recommendations. And yet, high-resolution soil data sets with national coverage do not exist. We either have small-scale data collection efforts with plot-level soil data or geospatial data with predicted soil properties, but at best at 250-meter spatial resolution. So against this background, we revisit the decomposition of gender gap in agricultural productivity in Malawi with longitudinal survey data and a focus on soil quality. And in the process, we conduct this unique data fusion exercise that leverages rich cross-country soil and survey data to be able to fill gaps in objectively measured soil quality. Our research relies on 3 data sources. The first are 2 methodological survey experiments that collected plot-level soil samples through a cross-country comparable and internationally recommended protocol. From a randomly selected sample of georeference plots, about 900 in Uganda and about 1,500 in Ethiopia. And these soil samples were then analyzed at World Agroforestry Center labs in Nairobi. The second data source is the Malawi Integrated Household Panel Survey, which is a nationally representative longitudinal household survey that has been implemented by the Malawi National Statistical Office. IHPS is a very rich data set, but also georeference plots, which is key to this analysis. And this georeferencing was done for all plots that were cultivated in each of the reference rainy seasons in each survey round. And for our analysis, we use the 3 survey rounds dating back to 2010. And our final data source is the AFSIS geospatial soil data set, which provides an area of predicted soil properties for the entire continent at 250-meter resolution. And these geospatial AFSIS data are then matched to our georeferenced plot locations in Ethiopia, Malawi, and Uganda. So to identify the contributions of soil quality towards the gender gap in agricultural productivity in Malawi, we need to address the fact that in Malawi, we do not have these objective plot level measures of soil quality. So we start out by estimating these OLS regressions of plot level soil attributes in our pooled experimental data from Uganda and Ethiopia as a function of these AFSIS soil attributes and other survey data. The soil attributes that we're interested in are in 5. They're key and documented widely in agronomic literature. We assess the out-of-sample model accuracy in randomly selected 30% of our pooled plot sample that is not used for model estimation. And we also assess the robustness of our predictions to using more computationally intensive machine learning techniques. And next, we apply these estimated model coefficients to the same set of AFSIS and survey predictors for the georeference plot locations in our survey data in Malawi, and subsequently predict otherwise unobserved plot level soil attributes. And then we construct 2 variants of this weighted soil quality index, which is a workhorse measure in agronomic literature, advanced by work by Mukherjee and Lal, and 1 variant based on the imputed soil level attributes in Malawi, and another variant based on the AFSIS soil attributes. We then move on to assessing the performance of these imputed measures vis-a-vis the geospatial counterparts in productivity regressions. So here we're going to be estimating 3 different kinds of regressions: a cross-sectional regression, a pooled cross-sectional regression with time fixed effects, and a linear panel regression with time and household fixed effects, taking advantage of the longitudinal nature of our data. And we're modeling here the plot level log total value of output per hectare as a function of the female management identifier, the soil quality index, and a rich array of plot, manager, and household attributes. In each of these specifications, we're going to be interested in how the coefficient delta for the soil quality index performs, and whether the magnitude, the direction, and the significance of the coefficient changes as a function of using the imputed soil quality index versus its geospatial counterpart. And the last step in our analysis will be to decompose the gender gap in agricultural productivity, where again, we're going to be estimating this regression of land productivity as a function of our entire vector of household, manager, and plot level attributes, including the soil quality index. We do this for the pooled plot sample and separately for the male and the female managed plot samples with and without household fixed effects, which we then use to decompose the average difference in plot level agricultural productivity between male and female managed plots. That is denoted as D. And that's split into various components. The endowment effect is the summation of the differences in levels of each covariate between male and female managed plots, valued at the coefficient for each covariate from this equation 1, estimated with the pooled plot sample. And then we have two additional components, the male structural advantage, which captures the differences in the regression coefficients estimated with the male managed plot sample vis-a-vis the pooled plot sample, and the female structural disadvantage, which again captures the differences in these coefficients between the male managed sample and again the pooled plot sample. So we start with the results from our prediction models for plot level soil attributes in our pooled Uganda and Ethiopia data. We follow a stepwise selection process and retain only the significant predictors from a longer list of variables. As such, the predictors that we use for each of the soil attributes vary across the columns. The R-squared values vary from 32% to approximately 60%. Decent measures vis-a-vis other within survey imputation applications, primarily on poverty and food security outcomes. The AFSIS-based measures are consistently significant predictors of all attributes, with the exception of one model. And while the self-reported soil type is a significant predictor in these regressions, the self-reported soil quality is not. So evaluating further the quality of these predictions in a randomly selected 30% of this pooled sample that is not used for model imputation, we see that the imputed plot level averages are not statistically different than the observed values, and the imputed averages, like the observed values, remain significantly different than the geospatial counterparts from AFSIS. Let's now look at the imputed plot level measures in Malawi, and although we cannot validate these predictions, we see that the pairwise correlations between the imputed organic carbon and imputed clay fraction, as well as the imputed soil quality, are as expected and in line with the literature. The same, however, cannot be said regarding the AFSIS geospatial measures at the same plot locations. In the plot level productivity regressions, we also see that the imputed soil quality index consistently takes on a positive and statistically significant coefficient, but the AFSIS-based index is never significant except when it takes an unexpected negative coefficient that is marginally significant. So going forward, we therefore use our imputed plot in soil quality index in our decompositions. And here are the decomposition results. We see that the total value of output per hectare is 21% lower in female managed plots. The endowment effect, again, driven by differences in levels of factors of production, explains up to 88% of the gender gap, depending on the specification, and higher soil quality on male managed plots exacerbate the gender gap in agricultural productivity, indicated by the positive and highly significant contribution of soil quality towards the endowment effect, and returns to soil quality do not appear to be otherwise different on male and female managed plots. And finally, up to half of the endowment effect and about 1/3 of the overall gender gap in agricultural productivity can be due to higher soil quality on male managed plots. So a few key takeaways. We've seen that the publicly available geospatial data are not appropriate for agricultural productivity analyses on smallholder plots, at least in our sample. We've shown the promise of imputing missing plot level soil attributes from geospatial data, but additional validation is needed. Imputed soil quality index has been shown to outperform its geospatial counterpart in our analysis and explains up to 1/3 of the gender gap in agricultural productivity. And finally, although not shown today, omission of the imputed soil quality index from the decomposition actually does alter our results, which generally leading to underestimation of the overall endowment effect. And also altering the composition of the endowment effect, overestimation of the contributions of these key inputs, the male labor input and the cash crop cultivation, and underestimation of the contribution of the fertilizer use. So with that, thank you very much.
Thank you, Talib, for a succinct and very interesting presentation. Let's move straight away to Kanika. For her, we move from Africa to now India. So it's her paper.
Yeah. So welcome everyone. Actually, Talib's paper ended on a very nice note because he was able to control for something that we're not able to control for in the context of India. But nonetheless, in this paper, we look at the same question as what Talib has looked at in the context of Africa. I'm not able to move my slides. The reason why we choose to look at India in this paper is because there is very little literature in general, as Beena mentioned, on South Asia. In fact, there was none for India when I started working on this paper. Whereas in India and in other South Asian countries, the role of female farm managers has been increasing over time because of certain factors that we'll discuss, but largely because of increasing male migration. So the national question is, are there productivity differentials in the context of India between male and female farm operators? And what are the factors that mediate these differences? And this is going to be the key question that we will try to examine in this paper and get some preliminary observational correlation evidence to answer these questions. Just to give you a snapshot of how female farm management has been changing in India in comparison to the other countries. So female farm operators range from 18% in Latin America and the Caribbean to 4% in Oceania. Estimates for South Asia peg them at a proportion of 12%. Agricultural census in India shows that approximately 13% of the operational land holdings were cultivated by female farm operators in 2010, and this has increased in the last 15 years by almost 4%. The operational area cultivated has also increased, but on average, this area remains lower than the operational land holdings because on average, women cultivators, they cultivate smaller parcels of land. There are some household level data sources which have recently started capturing information on female farm decision making. An Indian Human Development Survey has been doing that, which is a panel survey in its round in 2004 and in 2011. And the question that they ask the households, which we exploit in this paper, is who is the primary decision maker about farm matters in your house? In the survey, approximately 60% of the total rural households report owning or cultivating any agricultural land. And out of these 60% households, about 8% in 2004, which increases to 11% in 2011, report as having primarily females as taking decisions about on-farm cultivation of crops, etc. Just to show you the geographic variation on what is the geographic spread of the female operators in India. So we find that it's the hilly states of Himachal Pradesh and Uttarakhand, and to some extent Kerala and Tamil Nadu, and Bihar, which have the highest proportion of female farm operators in India. Now, the hilly states are also the states which have high rates of male migration in India. So here we just look at some of the factors that can perhaps give us some idea of, what is the geographic spread in India of these female farm operators. And we indeed find that states where there are more migrant spouses, females are more likely to manage farms in both 2004 and 2011. We also find that states where women are more likely to own land are also the states where they're more likely to manage the farms that they own. Now, unfortunately, we don't have data over time for female landowners. It's only available for 2011. Whereas we can look at changes over time in male migration across states in India. And what we again find is that there is a clear positive relationship between increase in male migration and a positive increase in the proportion of female who are managing the family farms. As has already been discussed, there is extant literature on sub-Saharan Africa, very little on the East Asian countries. On sub-Saharan Africa, the literature that looks at the productivity differentials between male and female managed farmlands begs the differences in the negative and ranging between 4% to 40%. Some of the studies use across household variation, the others use within households if men and women cultivate different plots of land. And the question that these studies try to answer is, is there a difference in productivities? And if there is a difference in productivities, is it explained by the observed differences across the male and female operated farms? Now, some of the mediators which have already been discussed by Talib, and I wouldn't go into the details, are the crop choice, input usage, credit and market access, the human capital resources available to men and women, as well as, most importantly, soil quality, which, as Talib mentioned, has not been looked at in, except for one or two studies. Not many studies have actually looked at that particular variable. But given this entire literature, there is again mixed evidence on whether the gender gap in productivities disappears or it remains after all the factors, after all the mediating factors have possibly been controlled for given the context. And there are many problems in getting positive effects. There are measurement issues, there are issues around unobservables, there are issues around endogenetic inputs as well. And now in this paper, we're not going to tackle pretty much none of these almost. We're going to just look at some of the correlations between the management and the productivity on the farm. Whereas an ideal experiment would have been if you give the same level of inputs and a similar quality of land to and just have a different male or a female farm manager. This is something that we cannot do in this study. However, there are some studies which have experimentally tried to vary a provision of extension services to male and female farm managers, as well as fertilizer subsidies and other inputs when given to farm managers. The econometric specification that we have is that we have as our dependent variable the log of value of output per unit hectare of land. On the right-hand side, we have an indicator variable for female farm management on the household farm, and then a host of control variables that control for the individual level controls, the household level controls, as well as input access. So just to give you a brief glimpse of the kind of controls we have. So the first two rows here give us the productivity measures that we use. So overall, we don't find that women have lower productivity than men, and that's largely because women cultivate smaller plots of land. But we do get a negative sign once we control for the land holding size of the farmlands. In terms of the nature of crops grown, we find that women on average grow more cereals as compared to cash crops or pulses. In terms of irrigation and other input usage, women on an average have, they use less irrigation, they use less fertilizer, pesticide, as well as irrigated water for purchase and credit as well. So a lot of the things which have been discussed in the context of Africa hold for India as well. Also, in terms of ownership of machinery, these households in which females manage farms have smaller access to machinery. But these households don't surprisingly differ on their asset score. So we don't really find much difference in the asset score here. So let me get to the results that we find. So here is the main coefficient of the female farm manager that we're interested in. And what we find is that controlling for land, there is an 11% smaller productivity on farms managed by women. And here we have village fixed effects as well. As we keep adding the controls, this negative gap falls and it reduces to 7% even after we have added all the controls that we have access to in the data set. We also conduct semi-parametric and parametric decompositions in the paper, but I'm not going to get into the details of these given the paucity of time. But to summarize the results that we find is that productivity and profits are lower on women managed farms in India by 7% even after all the controls have been added. And what a decomposition exercise shows is that crop choice and input usage remain the two most important variables which act as mediators in our analysis. Now, we try to test for other mechanisms which might be at play, given that we have a large proportion which is unexplained. Now, it could be unexplained, as Talib mentioned, because of paucity of soil quality data in our context. But one other mechanism that we would like to test for is the mechanism on limited knowledge and experience or information that might exist between male and female farm managers. And to get suggestive evidence around this, we do two types of heterogeneity. So first, we look at rice versus wheat as a crop. We do that because we know that women traditionally have been more involved with rice cultivation in India as compared to wheat cultivation. And the other heterogeneity that we look at is northern versus southern states. So northern states, women have on an average, they played a smaller role. Their involvement is less. So if you look at the wheat,
Kanika, just.
Yes, I think I'll be in time. So we find that for the wheat crop, the difference still remains even after we have control for all the factors. Whereas for rice, the difference becomes statistically insignificant and it also becomes very small after all the controls are added. We find similar results for north, where the gap doesn't disappear, whereas the gap disappears for the southern states. So to summarize the findings, the negative productivity that remains, which is large, which is 50%, even after all the controls have been added, it seems that some part of it may be explained by the lack of experience amongst the female farm managers in India. Let me stop here. Thank you.
Wonderful. Thank you. Perfect. Perfect time. Thank you. So I will now share my screen. Thank you both. If people has asked to start my video, start your video. Is there a video here?
We can see your.
Now we can see you, Bina.
Yes, we can see.
Yeah, no, this is just an instruction. I just want to mention that people who have questions on the first two papers, could you please put your questions in the chat? So we've had two papers, both of which show that female managed farms have lower productivity than male managed farms due to embedded gender inequalities such as poor soil quality, crop choice, input use, and managerial experience. Now, my paper also on India asks the question, would women's productivity and profits be higher if they cultivated in groups by pooling land, labor, and capital and sharing costs and returns? So it moves away from individually managed farms to compare for the first time anywhere the performance of all women group farms with individual small family farms, 95% of which are male managed in my study. Now, it's based on a primary sample survey undertaken in 2012 to 14 in the Indian state of Kerala, which began women's group farming experiments in the 2000s. And I've done comparative work for other states, but because of limited time, I will present my Kerala results today. Now, in principle, cooperation in farming can range from single purpose to multi-purpose to fully integrated. Globally, what you find is that single purpose marketing cooperatives are the most common, especially in the dairy industry. Amul in India, here, this is a picture, is one example. In between, we have multi-purpose cooperation, such as buying large machines and crop planning. But group farming involves fully integrated cooperation on a daily basis. Also, the farm collectives in my study in India are quite different from prior experiments, be they socialist, post-socialist, or currently European. The Indian groups are voluntarily constituted, egalitarian, managed entirely by women, and also they are a collective of individuals and not a collective of family farms. So they're based on the self-help group model. Conceptually, of course, we might argue that we would expect resource pooling and joint cultivation to bring in many economic benefits to small farmers in general, but to women farmers in particular. So, for instance, one could argue that group farming could increase access to land, enlarge farm size, and help reap economies of scale. It could help save on hired labor, provide better access to credit, inputs, and technical information. It would also bring in a greater diversity of skills and managerial talent than available with any one person or family. And it could enable measures to tackle climate change, thus providing more bargaining power with governments and markets. For women, less restrictions, if you work in groups, you're likely to have less restrictions on public interactions, ability to get over social norms, and can have more control over decisions and output. Now, the question is this potential realized in practice? So we consider the Kerala case. Now, the Kerala program began in the 2000s under the state's poverty alleviation mission, Kudumshri, and was supported by independently constituted community development societies, which is a network with elected women farmers. Now, the groups were constituted by women who were part of neighborhood groups doing savings and credit. And since few women owned land, they had to depend on leased-in land as the model with its attendant constraints. So the women lease in land, labor, and capital and share costs and returns. They also work on their family farms alongside. So there's a task rotation which enables them to do that. And these are their own farms are very small and there is labor surplus. Group farms receive some startup grant from the government, technical training, and they also have access to the subsidized credit from the All India Agricultural Bank. So what this does is actually provide some degree of level playing field for women relative to men, but not fully. And today there are 68,000 groups in Kerala that are functioning. Now, my research was based on a primary sample, as I said, a primary survey, where I compare group farms and small individual family farms of less than 2 hectares, 2 hectares or less than 2 hectares, in 2 districts of Kerala. There's Alappuzha. Kerala is here in southern India. And there's Alappuzha, which is dominated by subsistence rice production and also rice for sale. And Thrissur, which is dominated by commercial banana. And in both states, vegetables are grown. My sample consists of 250 farms, 69 all women groups, and 181 individual family farms. The individual farms are the family farms of the women members, but selected randomly from among them. Now, for these, we collected weekly data for every input and output for each plot and crop for an entire 12 to 13 months. And in addition, we did focus group discussion to get more qualitative insights on farm functioning. Now, the average group size is about 6. All the women are literate, and so are the men. What is interesting is that the groups are heterogeneous to some degree in caste and religion, and poor and less poor. Now, normally we would expect that heterogeneity goes against the common assumption that homogeneity is necessary for effective cooperation. But heterogeneity actually provides a wider social capital base for the women to access land and to ensure leadership. The average size of the group farms is 1 hectare, and of the individual farms is 0.35 hectares. So the average farm size for the groups is larger, but the individual farms all cultivate their own land, or mostly their own land, whereas the women are leasing theirs. Now, women's groups still face some disadvantages. Their dependence on leased land leads to high transaction costs in finding land, and the leases are rural because tenancy is not allowed. So it creates insecurity of tenure. It restricts access to government subsidies because you can't prove you're a farmer. Women also face what we know, as other papers have said, structurally embedded gender biases in access to land, inputs, extension services, and markets. And most have little prior experience in farm management, as Kanika also mentioned. And then the question is, they can face absenteeism, some collective action problems because they are in groups. But free riding is rather little since the women are all neighbors. Absenteeism is subject to rules of labor replacement and fines, which they do impose. Now, despite all these challenges, how do they perform? So here's my broad model. And what I have on the left-hand side is a log of the value of output per hectare. I test if this differs according to the type of farm, which is a dummy. And I control for a range of other factors, labor use, fertilizer and other inputs, irrigation, cropping pattern, the farmer's age and education, and district dummies. So I won't spend too much time on this because of limited time. There's a World Development paper on this, which can be read. And for a general audience, I thought I'd first present the crosstabs. And what is striking is that the groups actually do very well. So you find here that group farms relative to individual farms have 1.8 times the average annual value of output per hectare. And they do particularly well also in banana, where you have banana yields are about 1.6 times those of individual farms. Where they don't do so well is in paddy cultivation. And this is because they are unable to get the good quality land. Farmers don't lease out good quality land, they self-cultivate it. Now I present my regression results here, and as you can see, the group farms do particularly well after controlling for other factors. So if you have a shift from individual farms to women's group farms is associated with an increase in annual output per hectare of about 30%. And we have the usual positive. The cropping pattern effect is negative because we're looking at if there's no paddy or banana, then they actually do better. If they don't have paddy, then they do better. Here I've just shared with you the specific regression results for paddy and banana, and just the significant variables. And again, you can see that for banana, it's the group farms do very well. In fact, a shift from individual to group farms is linked to an increase in output of 348%. Now, some groups have negotiated contracts with local temples to supply special banana varieties. And because they are groups, they are better able to deliver on contracts than individual farmers. And there's much more trust also that they will be able to do so. Now consider the net returns. Now, these are calculated by deducting all paid out costs from the total value of output. But I haven't imputed any values for owned land or family labor. And here we find that the mean net return per farm is 5 times higher than that of the individual family farms. And it's actually 3. If you look at that year's data, then it's 3 times more than the state average for that year. So let me then conclude that what is interesting is that under COVID, of the 30,000 group farms which were harvesting in March of 2020, 87% survived economically under lockdown, while large numbers of individual farmers lost out. And then other work that I've done in East and West India, there also it was reported that group farms, they said that they were much more food secure than if they were doing individual farming. So I want to conclude with this, comment that, is it the case that the institutional innovation of group farming could provide the key to bridging the gender gap in farm productivity? And if so, then perhaps there is a policy measure here to be thought about more widely in Asia, Sub-Saharan Africa, and possibly also Latin America. So thank you. I hope I haven't exceeded my time. I pass now to Chris for his presentation. Thank you, Chris.
Thank you very much, Bina. I'm happy to be here, and thank you all for joining us. So we'll now transfer back to Africa, and I'll give you some results from a project with a number of co-authors looking at how gender, social networks, and information about agricultural technology interact in northern Ghana. So this is results from a study that's gone on for 4 years, covering 162 communities in 9 districts across the northern region of Ghana. About 3,200 households participated in this work with us. And I want to focus on one dimension of this work, which was a agricultural extension program called a community extension agent. In a set of randomly selected communities within our study area, we selected one individual from the community to be trained as a community extension agent, essentially an assistant for the agricultural extension agents of the Ministry of Food and Agriculture. This agent was provided with 1 month residential training, and in each season of the 4 years of our study, this agent was responsible to deliver about 30 messages weekly to 10 farmers who were randomly selected within that community. The messages were delivered on videos, on tablets that we provided for the extension agent, and they were developed in collaboration with the Ministry of Food and Agriculture to deliver the basic extension curriculum for northern Ghana that the Ministry of Food and Agriculture had developed. The messages were timed to the activities that the farmers were doing on their plots that week. And so depending upon what that farmer was planning on doing that week, they would get the appropriate video message for that week. So it followed the flow of farming operations over the season, and it provided an opportunity for farmers to get feedback from the extension agent. The farmer could ask questions, and the extension agent could then relay them to their supervising extension agent from the ministry and provide feedback to the farmers. So it was a very interactive multimedia experience. So this is one of our community extension agents with his tablet working with one of his farmers. So the feedback was intensive. We got about 12,000 questions each year going back and forth between the farmers and the extension agents. The informal feedback that we received from the farmers was extremely positive about this. The farmers who were provided with the service were enthusiastic about the treatment, thinking that it made a very or extremely positive difference in their lives. Almost all of them agreed with the statement that meeting with this community extension agent has led me to change some part of my farming practices. Okay, so that's what we're going to look at. How are we going to look at it? We've got 162 communities, and we have a sample of 20 households within each community that we've been following for these past 4 years. We divide those communities into 2 groups, a control group and a treatment group. So 81 of those communities did not have a community extension agent, and in 81 of those communities, they did have a community extension agent. And within those communities in which there was a community extension agent, we assigned 10 households to that agent, where the randomly chosen households that agent was responsible for meeting with every week to provide these messages. And then there were 10 other control households the agent was not assigned to treat. We combined that with network data, social network data. So we asked each individual within our sample of 20 households about individuals in the other sample households within their community. Questions like, do you know X? Do you know that person? Are you related to that person? Have you ever discussed the management of your farm? And has that person ever worked on your farm, or have you ever worked on his or her farm? And we examine this between household heads to household heads, spouse to spouse, and spouse to household heads. We're trying to look for individual connections across these different households. Okay, what do we find? What we find is first that the community extension agent treatment improves the knowledge of farmers. We gave farmers in our sample quizzes about the material that was covered in our curriculum. And we also gave them placebo questions, questions about agriculture that were not covered in the curriculum that we provided. Non-treated households, farmers who were treated, who were assigned to the treatment from the community extension agent, scored better on the questions in our curriculum, but they didn't do any better on the placebo questions. But what's particularly interesting is that non-treated households in the communities with extension agents also did better than pure control communities. So here's a summary of these results. The dotted blue line of the tests is the distribution of test scores on questions related to the agricultural curriculum for women in our control communities. The green dots are the distribution function of the scores of women who were treated by the community extension agent. So the treated woman answered more questions correctly. Similarly, the solid lines are for men. The men scored better in the control group than women did, but the treated men scored better than the untreated men. So both men and women learned from the extension agents. And that red line in between are the scores of untreated farmers in the treated communities. So they did a little bit better, but not as much better as the people who had the treatment directly. But they didn't just know what we taught them, they adopted the practices that were encouraged by the treatment. And so these are a series of the left side of this figure, from record keeping through organic fertilizer use, were practices that were encouraged during the extension program. And so, for example, germination testing and row planting was much higher amongst those who received the treatment than those who didn't. There was no recommendation in the program about another set of practices, and then not burning. It was recommended that farmers not burn their fields. So what we find is that farmers adopted the practices that were recommended. But we can go further than that. We see that there's learning, we see that there's adoption of practices, but we can see exactly the flow of information and the flow of practices through social networks. Household randomization implies that conditional on the number of people in your social network, the number of farmers in that network who received the treatment is random. And so we can look at, conditional on how many people are in your social network, do you respond better to our exams, or do you adopt practices more when somebody in your network was treated? And we can see that that's true for at least men. If we look at the social networks of men, the blue graph, if they have an additional member of their social network who is randomly treated with the community extension agent treatment, they are able to respond more correctly to our questions on farming knowledge. We don't see that effect for women, but we can go a little bit further. We can see if it's the social networks of men, whether it's the men in the social networks of men or the women in the social networks of men who are treated that affect farmer knowledge. And what's stunning in this graph is that for both men and women, it appears to be the number of treated women in their social networks that has a bigger influence on their knowledge than the number of treated men. So this is the effect, excuse me. Page pointer. This is the effect of, on those test scores of men, the number of treated women in their social network has a bigger effect than the number of treated men. Similarly, the test scores of women go up more when they have more treated women in their social networks than the number of treated men. Okay. But this knowledge transmission seems to be mediated by the household. What this graph shows us is that if we look at the number of treated households in the male network, that is the network of men, if a man knows somebody who's treated, we see no effect on the effects on his own test score or the test score of his wife. Similarly, we see no effect on the test scores of the man or the wife of treated households that his wife knows. Well, where we see the effects of the network is when both the husband and the wife know someone who is treated. So there's something going through the household. When both the man and the wife know somebody who's treated, that's when they start learning. We see something very similar with practices. Take just one example of practices, whether you actually plant in rows. What we see is that both men and women seem to plant in rows more when they know somebody who's also been given the community extension agent treatment. And again, it appears to be knowing women who are treated that have the biggest effect on whether you adopt row planting. But what we see, again, when we look at the household itself, if only the husband knows somebody, both the husband and the wife are more likely to adopt row planting. If just the woman knows, there's no evidence that that makes a difference in row planting. But when both the man and the woman know the person in the other, both know someone who's treated, that's when they're most likely to adopt practices. And so what seems to be going on in northern Ghana is that information about new practices flows through social networks. The adoption of those new practices follows that flow of information through social networks. The connections to women who are trained is specifically powerful. It's more powerful than connections to men who are trained. But these effects are reinforced when links are shared by spouses, when both the husband and the wife know the other person who's treated. That's when we really see the adoption of new practices come into play. Thank you all very much. I appreciate it.
Thank you, Chris. Thanks. That's fascinating. So, are there any questions? Because on the chat there was a discussion between Kunal and Kanika, and I had something put in, but there weren't any general questions. I would suggest all the panelists just unmute themselves, and if they had questions to each other as well. So Chris, I had a question. Does the learning, this is so interesting because in the training in my sample, it was given by the government, they actually carried over some of the information of new practices to their home plots as well. Uh-huh. So, but it couldn't be, so in fact, the fact that they did so much better indicates that something more is going on because there is a group. Now, being educated, does it make a difference? I mean, the women and men, because their ability to absorb training would matter.
Absolutely. The women have essentially no education in our sample. The men have a little bit of education. And so there is a notable educational difference, and that may be playing part of the mediating role. But it's in a surprising way, right? The fact that women being treated seem to have a bigger effect than men being treated on other people's learning may have something to do with the fact that the marginal improvement in their knowledge due to the treatment is bigger for women than for men. So that is our hypothesis on that effect.
I see. Right. Kanika
And
is
yes,
asking,
the
but
extension agents
Kanika, you can unmute yourself, but the extension agents all men?
Yeah, unfortunately, we tried desperately not to have that, but we weren't able to avoid that.
And did they have only one-on-one sessions, or were they available on the phone?
It started off as one-on-one sessions, but we found that so our CEAs were required to document that they met the people they were assigned to, but other people came to them as well, and other people joined the group sessions.
Groups.
Chris, women tend to be much more sociable and much more generous with their knowledge. I mean, since you've been working on this qualitatively in the field for so long, you would have a sense of that, because there are other network studies which seem to suggest that women share knowledge without feeling it's their property, and men may not share it in the same way.
I think that may be part of the reason why the connections to women are more important. And the fact that it's when the husband and wife both know the other woman, that's when the big effect is taking place. So I suspect what's going on is that the women are more likely to share with both, the women who are treated are more likely to share with both the husband and the wife of some other family. And that's when the knowledge really flows.
Okay. Kanika, yes, Talib, go ahead. And then I'll read out Kunal's question to Kanika. Go ahead.
Okay. No, I think very quick question to Chris. Trying to link it back to this the evidence on potential soil quality differences between male and female managed land. So I was just wondering the extent to which the community extension agent advice took into account any observed or objectively tested soil attributes when they were working with respective male and female farmers.
Yes.
Let me, before you answer that, Chris, I'll add another question from Arti Krishnan, who says, did you have much, is there a spatial effect? Was there spillover learning within specific regions where they reside? And maybe it got diluted as it moved forward.
Great question.
Since we're running out of time, I'll read out the question by Kunal, which Kanika's partially answered, asking, is there a selection bias that male farmers tend to leave those farms which are less productive? So I just thought it could be shared with the audience as well. So go ahead. First Chris, then Kanika.
Okay, no, there was no adjustment to objectively measured soil quality, but there was a major portion of the curriculum which was about choosing a match between crop and practices and observed soil characteristics and topographical characteristics. And that actually relates to the geography question, which is there spatial spillovers as well? Women do tend to farm plots differently located than men's plots. And we have not yet looked at the spatial correlations of women's versus men's plots and the spread of these practices, which is actually a really interesting idea. Okay. And Talib, I have just one quick question for Talib, which was, have you considered the possibility that there might be a different mapping from observed characteristics to objective characteristics of land of men and women, because they have different models of how soil works?
Okay.
So yes, Talib, Chris, actually,
can we first come to Kanika quickly, and then on Kunal's question, and then come to Talib?
I agree with Kunal. In our paper, there is selection bias, and one cannot get rid of it completely. To a certain extent, what we do in the paper is we look at men and women within the same village, and we do a robustness check where we drop the villages in the areas where the migration rates, where the male out migration rates are very high. So that, just to make sure that our results are not just being driven by regions which have very high male out migration rates. So these are the two checks that we do in the paper.
And in response to my comment on this, which was that when men migrate, it's not necessarily spouses. So if your distance of migration will matter. If you're within the rural areas, you're just setting up a carpentry shop, then you're still going to be able to make decisions, even if the woman is overall seen as a manager. Distance of migration, is it something that you can bring in?
Unfortunately, no, because ISDS doesn't capture overall migration. They just capture the spouse migrated.
I see.
So we're not able to look at that.
Okay. Thank you. Talib, did you want to do?
Yes, Chris, actually, may I ask you to repeat your question? There was some interference on my end.
Sorry, I was wondering if it's possible that men and women might generate different mappings between observed soil characteristics and scientifically measured soil characteristics because they have different kinds of land or different models of how the land works.
So thank you, Chris, for the question. That's entirely possible. We have not looked into this correspondence between subjective and objective soil measures by basically gender of the plot manager. But I think the data allows us to do that, as well as some of the previous experimental data. So I think that's definitely a direction we can look into.
Yeah. Did any of you have responses to my group farming, approach? Chris?
Yes, I was wondering whether there was any evidence about your individual farms were individuals who were members of the group as well, and so.
No, not all of them. Not all of them. Yeah.
Okay. Do we understand anything about how the choice of what land to allocate to the group versus their own farms, how that was made?
Okay, so the group farms are not using the individual family farms, or very rarely. So basically, they are leasing in land, unless you're a widow. I mean, those are not very many cases. If you're a widow, you bring in the land, and that's also leased by the group. So they are paid the market rent or whatever is negotiated.
Got it.
And so they are quite separate. Right. And that's also the transaction costs of trying to find that land as well.
Do the groups acknowledge and try to deal with the tension between individuals who've got great land might be tempted to not show up for group activities?
Yes, so here they have systems, because if there's absenteeism, they have to either substitute the labor or they have to pay a fine. They actually impose that. But they are part of neighborhood groups. So the way the program was set up is that they would be in the neighborhood, that they would know the reasons for absenteeism. And so the kind of problems that in other regions in Eastern India where I've done this work, and there are male groups or mixed groups, you find that absenteeism and some kind of, free riding is there, and that causes a degree of conflict. And they are trying to sort that out, but not in the all women's groups in Kerala or in Telangana, where I also did this work. The soil question, Talib, that you asked, the plots, you can't actually, because the plots are not separately allocated. So if a household has its family, the structure of the farm is that the family cultivates. So even if you buy inputs, they're not bought per plot. And so the kind of separation you can do between women's plots and men's plots in sub-Saharan Africa is really not possible to do in the Asian context, I would say, not just the South Asian context.
Bina, can I ask you something about the structure of the farm? Is it
Yes.
in a group farm setting, is it more fragmented or as fragmented as individual farms? Like when we're actually talking about specific plots?
It's more fragmented in the sense that you may cultivate 3 plots. the family farms are much more consolidated, whereas the women's plots, if they want to cultivate 1 hectare, they may have to go to 3 different landlords, and they are not necessarily spatially, contiguous. Now, this is particularly the case here, but a very different group farming experiment done in Bihar and North Bengal. They form the groups by first ensuring that there are contiguous plots. So it really depends on the availability of land locally.
Okay. But it seems to me that this issue of trying to understand this otherwise unobserved heterogeneity in land would still be applicable in this case, because you're still talking about pieces of land which we can be assessed for basically objective soil quality measurement.
It's we don't have that data. What I have is irrigation.
Right.
So
no, I know you don't,
yeah.
but in the setting, I mean, going forward, sort of, in future work, the role of those unobserved attributes, yes, could probably be explored. I mean, Chris and Doug Gollin have a recent paper. I don't know if you have seen that. They look at this question around misallocation, and they do sort of reveal this importance of unobserved plot level heterogeneity in explaining productivity outcomes. It's for the African context, but it is one of the motivating papers for our work.
Okay, thank you. I have a question here to me. Do within group dynamics between members also have implications for productivity? In your case, the within group, it's not, there's not enough conflict, obvious conflict for one to be able to measure that. So there are cases where people don't turn up for work and then they may be fined. But overall, the number of such cases are not very large. It would be an interesting question that do groups split up? Typically, they don't split up unless a woman leaves and she migrates out.
I have a question building on that. Oh, sorry.
Yes.
No, Chris, go ahead. You go ahead first.
So it's just building on that same question, which is the idea of cross-religion and cross-caste groups is really intriguing. And do you think this might be a program that could actually change the nature of caste and religious interactions within communities?
It has to some extent be transformative, because there are 2 reasons why they did it. One is that they are heterogeneous neighborhoods, but there are caste issues. There are scheduled castes, for instance. So when the group meets, initially the upper caste didn't want to have a meeting in the low caste with the low caste women's house because they had to have tea, and then the group said, "Look, do you want to be in the group or you want to be out of it?" And they settled in. There's work by the Self-Employed Women's Association, very interestingly, where they show that women tend to get over intercaste differences much more easily, because they say they're not politicized. So they treat caste as a social factor rather than being connected politically through caste networks to political parties. So that I thought was an interesting variable as well.
Bina, actually, I had a very related question. So I was just thinking about this heterogeneity in group composition in terms of specific background attributes. And obviously that's going to be, certain types of heterogeneity is going to be increasing the costs of cooperation. And then probably there are other mitigating factors. So I was just maybe more thinking about these mitigating factors, meaning the factors that decrease the cost of cooperation within a group setting.
Yes.
In the presence of heterogeneity, this type of like caste, religion, or other ethnic heterogeneity that I personally obviously don't clearly understand, but you would know.
So it's a good question, and actually my paper, because I didn't have time today, I compare 2 states in the World Development paper. I bring in Telangana, where the groups were proactively constituted of scheduled caste women I mean, very homogeneous. So they didn't go for the heterogeneous model. They were also very large groups. And what I found was that the social capital that these women had was very limited, because scheduled castes are already disadvantaged in terms of the access to land. So the women's ability to get land from upper castes was very, very restricted. And this comes out in the qualitative, analysis, where they are constantly saying the upper caste landlords will not help. So they are low caste and disadvantaged, and that doesn't really help them. So you're right that there are degrees of heterogeneity. So I think class heterogeneity matters much more in a sense in the Kerala case, and they're all quite within the same range across class lines. But India is a very diverse country, so caste can be very divisive in some regions and less in other regions as well. But I think what I challenge is the idea that homogeneity is an essential condition for cooperation to succeed. And here, the advantages of heterogeneity are very obvious, because they are leasing in land and they use a vast number of networks across castes and so on to get land and inputs and so on. But this is something for Chris to study. Would be very interesting. Chris, for your next project, maybe you should have it in India.
To join you.
So,
Kanika.
Kanika, did you have anything more? I mean, we should, we're continuing and we're recording, but I think I would say that if anybody in the audience wants to speak or ask a question, please let me know. Just put your name down in the chat, and then I can allow you to speak. Kanika, did you have any comments?
No, I've probably spoken to you earlier about the paper and the findings. Like, of course, you didn't get time to present the Andhra findings from Telangana, but yes, I think the contrast in the paper, which contrasts the model in Andhra to Kerala, was very illuminating, because one really understood the how access issues, how group sizes, a lot of different flavors came in. Came in the paper, which of course were limited here. But I think that's one of the fascinating aspects of
so I would very much welcome Talib and Chris. The paper is available. I'll send you a PDF, but it's in World Development. And this, as Kanika says, for me the contrast was very interesting because of very large group size in Andhra. They had one group per village. It could be, the average group size was 22. The max, it ranged from 14 to 50, and that was way too large. They were homogeneous in terms of caste, and the settlement patterns in Telangana also different, because their settlements are a bit outside the village if you're scheduled caste, whereas in Kerala they're much more integrated. So these factors one can discuss, but in a 10-minute presentation it's quite difficult. So thank you, Kanika, for that. So as a result of my paper, actually in Telangana, they've changed the program. So they have actually now reduced the group size to 10 women more consistently. And there were other recommendations that I made. I made recommendations to Kerala also, and they followed through some recommendations because they didn't have enough scheduled caste women. So it was not inclusive enough, and they actually proactively have done that since, from what they wrote to me. So shall we, I don't see any more questions in the chat. Shall we wind up? But I hope we can, firstly, thank you very much to all the participants, everybody who's been listening in and hearing the presentations. You can always write to us with more comments when you've had a chance to read the papers. All 4 have papers Kanika's and mine are in World Development, published in 2018. And then Chris and Talib, you would have working papers, right? And I hope the four of us could have another conversation about some of these issues. And I'm very happy to set up a Zoom link when you have time and you've had rested from your teaching and before the next teaching session starts. So thank you all, and be safe and keep well.
Thank you.
Thank you.
Thank you very much. And thank you to the organizers. This was great.
And thank you to organizers, to Andrea and the team who has been helping us so well. Thank you.
Thank you all.
Recording stopped.